Bismillah ar-Rahman ar-Rahim. In this video, I'm going to talk about L'Hopital rule. This video part 2, limits of 0 over 0 related to the trigonometric function and exponential function. So if we have limit x approaches 0, to find limit x approaches 0, sine 3x over x. Clear here, this is equal to sine 0 over 0. So that is mean I have a 0 over 0. So now to find the limit of this one is equal to limit x approaches 0. The derivative of sine 3x is cosine 3x times the derivative of the angle, which is a 3 times a 3, over the derivative of x is 1. So equal to. Now we have here 3 multiplied by cosine 0, which is cosine 0 is equal to 1. The answer is equal to 3. The answer is equal to 3. Another example. To find limit x approaches 0 for sine 5x over sine 3x equal to limit x approaches 0. Again, here I have sine 0, which is 0, over sine 0, 0. So we have 0 over 0. So the limit will be equal to, so the derivative of numerator is cosine 5x times the derivative of 5x, which is 5 multiplied by 5, over the derivative of sine 3x is cosine 3x multiplied by the derivative of the angle of 3x is 3 multiplied by 3, and equal to 5 cosine 0 over 3 cosine 0, because x equal to 0. So this is 1 and this is 1. So the answer is 5 over 3. Okay. Another example. Let us define the limit. Define the limit of x approaches 0 be 2x, and we have minus 1 over sine 3x. Now x equal to 0, e to the power 0 is 1, because we have e to the power 0, 1 minus 1 is equal to 0. Sine 0 is 0, so you have 0 over 0. Now, the limit of this one, again, by using the L'Hopital rule, the derivative of numerator, limit x, the derivative of numerator is e to the power 2x multiplied by the derivative of 2x, which is 2, multiplied by 2. Then minus the derivative of 1 is 0, over the derivative of sine is cosine 3x multiplied by the derivative of the angle 3x, which is a 3, is equal to 3. Now equal to 2 e to the power 0 over 3 cosine 0 equal to e to the power 0 is 1 and cosine 0 is 1. So the answer is 2 over 3. The answer is 2 over 3. Another example. To find limit x approaches 0 for tan x. Okay, tan x over sine 2x equal to tan 0 is 0, sine 0, 0. So you have 0 over 0. Okay. So the limit will be equal to limit x approaches 0. The derivative of tan is secant squared x, and the derivative of angle x is 1, over the derivative of sine 2x is cosine 2x multiplied by the derivative of the angle 2 multiplied by 2. Now, equal to limit x approaches 0. Here I have. So x approaches 0. The limit of secant square is secant square 0, which is 1 over 2 cosine 2x will be 0. 2 by 0 is 0. I think direct is 0. Now this is equal to secant square of 0. It is 1. And cosine 0, 1. So the answer is 1 over 2. The answer is equal to half. Another example. I write it here. To find the limit this example, x approaches 0. Here I have, or x approaches 0 for sine 3x over 7x. Clearly, this one will be 0 over 0. So the derivative will be cosine 3x times 3 multiplied by 3 over the derivative of 7x is 7. So now the limit x approaches 0 equal to cosine 0 is 1. So the 3 over 7. 3 over 7. Another example. That's it here. Let's put down. To find limit x approaches pi, and here I have sine x over pi minus x equal to sine pi is equal to 0. Pi minus pi is equal to 0. So the answer is equal to limit x approaches pi. The derivative of sine, because it is 0 over 0, is cosine, and the derivative here minus 1. So then equal cosine pi over negative 1. Cosine pi is negative 1. So negative 1 over negative 1, so is equal to 1. Another example. To find the limit of theta approaches 0 for 15 multiplied by sine theta minus theta over theta cube equal to, if we put 0, sine 0, 0. So this will be here 0. And this is 0. So the answer will be 0. 0 cube, 0. So you have 0 over 0. 0 over 0. Now, the limit is equal to limit theta approaches 0, 15 multiplied by. The derivative of sine theta is cosine theta minus 1 over, this one is 3 theta squared, because this one theta cube, so be 3 theta squared. Then cosine 0 is 1 minus 1, also you have 0 over here is 0 squared will be 0, again 0 over 0. So then equal limit theta approach 0, 15 multiplied by cosine x is negative sine x. So cosine theta negative sine theta over 6 theta over 6 theta. Now, this one is limit theta approach 0, negative 15 sine theta over 6 theta equal to, so we have sine theta 0 and 0 over 0. So we have 0 over 0. Again, L'Hopital rule is equal to limit theta up to 0, the derivative of sine will be cosine, should be negative cosine theta over 6 over 6. So now cosine 0 will be negative 15 cosine 0, which is equal to 1 over 6. So the answer is negative 15 over 6, which is equal to divided by 3, negative 5 over 2. Negative 5 over 2. Another example I wrote it here. To find limit x approaches pi over 4 for sine x, which is 1 over radical 2, minus cosine. Pi over 4 is the sum of the sine over x minus pi over 4. So this one also we have 0 over, because there's the same sign as cosine at pi over 4, and pi over 4 minus pi over 4 is 0. So still we have 0 over 0. So equal to limit of x approaches pi over 4. The numerator is cosine x, and the derivative of cosine minus sine will be plus sine x, and the derivative of x is 1. So now this equal to, well, this one is radical 2 over 2, or 1 over radical 2, plus the same radical 2 over 2, which is over 1 over radical 2. So then the answer is radical 2. The answer would be radical 2. Okay. Now, another example, I write it down here. To find the limit of theta approaches 0, cosine theta minus 1 over theta squared equal to. Now, cosine 0 is 1. So 1 minus 1, 0 over 0 squared, 0. So this one, 0 over 0. So now, by using the L'Hopital rule, equal to the limit, theta approaches 0. The derivative of cosine is minus sine theta, and 1 is 1. Theta squared is 2 theta equal to. Now this one again 0 over 0, so it'll be minus cosine. Derivative is theta over 2, which is negative 1 over 2. So I stop here. So these are the examples are solved, all relate to the L'Hopital rule from the beginning of example 1, which is 0 over 0, up to this the last one, which is we have here limit cosine theta minus theta over theta squared. The derivative will be negative sine theta over the derivative of theta squared 2 theta divided by 2 theta, and sine 0 0 still on 2 by 0 0. So we have to find the derivative again. Sine is cosine, and the derivative of theta is 1. So it will be here negative 1 over